Hello everyone, welcome to this video on the subject effective technical communication. Today we are going to talk about complex problem solving from module 5. Problems we know are a part of our lives. All of us, sometimes or the other, face problems. These problems can be personal problems which we face with our family, or it might be a problem which we might face professionally, that is, at our workplace. Problems will always be there, but we need to understand how to solve these problems in the most efficient and effective manner so that it leads us to be confident and mature human beings. Well, if we had to define what is a problem in a global way, certain phrases or certain sentences which we might have used ourselves or might have heard somebody else using it, certain things like, as you all can see on the slide, everything is going wrong, he or she will never change, there is no hope. We might have used these phrases many a times. Well, in a global sense, a problem is all of these when we use. So, further defining problem, we can say that problem is a gap between the existing state and the desired state. It is actually an obstacle or a hindrance that can cause interruption in the work that has been undertaken. Problems can be encountered at any stage in human life, and in the development of a project or in solving issues or education, uh, everywhere. Now let's see what is problem solving. So it is actually a systematic approach to define the problem, that is a question or situation that presents uncertainty, perplexity or difficulty, and certain creating a vast number of possible solutions without judging these solutions. Now, learning more about the complex problem solving, we must understand what is complex problem solving. So, problem solving we means different things in different disciplines actually. In psychology, problem solving is dealing with problems occurring in life. Sometimes the solutions are usual ones and sometimes they may vary. So, there are two types of problems. Sometimes it is well defined and it is also ill defined at times. Defining well defined problems, a well defined problem has a specific goal and an expected outcome. Well defined problem allows initial planning, whereas ill defined problem is abstract, and ill defined problem requires understanding at the initial level, and then we might work on the solutions. Sometimes a problem has to be solved while dealing with its pragmatics and semantics. So it may also involve abstract thinking. Coming to complex problem solving, we all know simple problems have usual solutions and they may happen to recur in time, whereas complex problems need to be dealt with a more formal approach. For example, if a glass of water has been spilled on the floor, it does not require analysis or any kind of interpretation or understanding to solve it. It can just be wiped off and the problem is solved. But if an entire setup is made to manufacture a product and the result does not outcome as expected, it may require proper understanding, observation, analysis, and research to identify where the problem is and then solve it. So, such problems which requires in-depth understanding, observation, analysis, and research is called complex problems. When a formal approach is required to solve a problem, we understand that it is a complex one. And also, the more time a problem takes to find an effective solution, the more it is complex. So, a problem may be complex if it is dynamic in nature, it has commencement and continuation capacity, or if it is inexpressive. That is complex problem solving. Now, let us learn about how we can solve these complex problems. So, here I have outlined few strategies of complex problem solving. It first starts with abstraction. The abstraction is nothing where solving a problem in a model of the system before applying it to the real system. That is abstraction. Next, number two is analogy. Analogy is where you compare two things of their being alike in some way. The similarity is determined and the solution that solves the problem is used to solve the existing problem. The next one is brainstorming. Here, brainstorming is the process of suggesting a large number of solutions, combining and developing them until an optimum solution is found. That is brainstorming. Next is divide and conquer, which is very important and popular. So, breaking down a large problem into smaller units to ease the solving of it. It is divide and conquer. Then we have lateral thinking. Lateral thinking is where you approach solutions indirectly and creatively. Next, it says means ends analysis. That is where means end analysis means where you choose an action at each step to move closer to the solution. Then we have morphological analysis. In morphological analysis, we assess the output and interactions of an entire system. Then we have proof. In this technique, we try to prove that a problem cannot be solved. The point where the proof fails will be the starting point for solving it. That is the strategy. Next is reduction. So, reduction or transforming the problem into another problem for which solutions exist is reduction. Next we have is research. In research, what we do is we employ existing ideas or existing solutions to similar problems. And the second last is the root cause analysis. So, in root cause analysis, you identify the root cause of the problem and you solve it. Finally, we have the trial and error method. So, we test possible solutions until the right one is found. That is the trial and error method. So, the solutions to complex problems can be generated using all these strategies. It is a common practice to use a combination of more than one strategy to arrive at a solution. That is mentioned here. Next, let's learn about the methods of problem solving. So, we all must know that complex problems cannot be solved with just intuition. Problems of the industry or organizations or production units require a lot of brainstorming. The problems may be ones that have never showed up earlier or maybe a different version of the usual problems. Whatever be the case, the problems are to be dealt with planning and proper approach. So, some of the tried and tested methods that can prove useful in solving complex problems have been listed here, which starts with 8D method. Then we have the GROW model, then how to solve it. Then we have the OODA loop, the PDCA cycle, the root cause analysis, the TRIZ method, system dynamics, and the hive method. Let's take each one of it and learn how does it works. So 8D method it stands for 8 disciplines. The 8 disciplines problem solving method, this was developed by Ford Motor Company. And this 8D method of problem solving follows the PDCA, that is the plan. P stands for plan, D stands for do, C stands for check, A stands for act cycle. And The 8 Ds, the 8 disciplines are, starts with D0 to D8. So D0 is plan. Then we have D1, that is use a team. D2, describe the problem. D3, develop the interim containment plan. D4, determine and verify the root causes and escape points. D5, verify permanent corrections for the problem. D6, define and implement corrective actions. D7, prevent system problems. And D8, congratulate the main contributors of your team. That is the 8D method. Here you just need to know the full forms and the how the 8D method works. Next we have the GROW model. So GROW model describes 4 steps to solve a problem. G stands for goal, that is where the client wants to be, that is the goal. R stands for reality, that is where the client is now. O stands for obstacles, that is the obstacles in solving the problem and the options available. W stands for way forward. Third one is how to solve it. So this particular method was developed by mathematician George Polya. It is a small volume describing methods of problem solving. Here we have 4 principles. 4 principles suggest that we understand the problem, firstly. Secondly, we make a plan. Thirdly, we carry out the plan. And fourthly, we look back on our work. That is the 4 principles he suggests in this how to solve it method. Next, let's talk about OODA loop. John Boyd of the US Air Force developed an iterative feedback model, what is now known as the OODA loop, after his experiences in the dogfighting in Korean War. Since then, it has become one of the popular decision-making frameworks in the world, both in professional and beyond. Boyd's OODA loop is often depicted as a simple 4-stage linear cycle. The cycle begins, as you all can see, with an observation, which leads the participant to orient on possible options, then decide on an appropriate course of action, and finally act on the decision. Next we have is the PDCA cycle. This is also known as Shewhart cycle. In the PDCA cycle, it is a continuous loop of planning, doing, checking and acting. It provides a simple and effective approach for solving problems and managing change. The model is useful for testing improvement measures on a small scale before updating procedures and working practices. The PDCA approach begins with a planning phase in which problems are clearly identified and understood, and a theory for improvement is defined. Potential solutions are tested on a small scale in the do phase, and outcome is then studied and checked. Next, we go through the do and check stages as many times as necessary before the full polished solution is implemented in the act phase of the cycle. That is the PDCA cycle. Let's go back to the 6th method of complex problem solving. It is the root cause analysis. So it is also called RCA. The root cause analysis method follows 4 principles. The first principle says define and describe the problem properly. Secondly, we establish a timeline for normal situation until failure has occurred. Thirdly, we distinguish between the root cause and causal factors. Once the root cause is defined, solution can be implemented. That is the root cause analysis in brief. Then the seventh method is the TRIZ method. So TRIZ is actually a Russian acronym. The English acronym is TIPS, TIPS, where T stands for theory, of, I stands for inventive, and P stands for problem, S stands for solving. So, theory of inventive problem solving. The TRIZ practitioners apply three findings in order to improve services, products, and systems. So, they assume that problems and solutions are repeated across industries and sciences. Next, they assume that patterns of technical evolution are also repeated across industries and sciences. Thirdly, they assume innovations use the scientific effects outside the field in which they are developed. So, that is the TRIZ method. Let's next talk about system dynamics. So, this is basically a mathematical modeling technique to frame, understand, and discuss complex issues and problems. This approach to understanding the nonlinear behavior of complex systems over the time using stocks, flows, table functions, and delays. That is the system dynamics. Let's talk about briefly about the hive method. Hive method is also called swarm intelligence. So it is the collective behavior of decentralized self-organized systems, natural or artificial. It is employed in work on artificial intelligence. It refers to a more general set of algorithms. That is the hive method. So these were the different methods of complex solving. After listening to the video, we need to also solve the questions. Hope the video makes it clear about the problem solving methods. Thank you.